And welcome everybody to the Daily Space Weather. We've got another coronal mass ejection to report on, some additional sunspot activity, and more. First, here's a full disk SDO movie. So we've actually got two new sunspot groups, this one up here and this one down here, in addition to this huge Sunspot 2882. And we'll show you some intoxicating close-ups of that at the end of the video. Here's a composite image. The last one was 171 angstroms. This is 171 and 304 angstroms. That's ionized iron and helium. And the coronal mass ejection we're talking about came out of this area right up here. You can see a filament moving down right in here, and that sort of went off to the west. Great view of that. We'll show you that in a minute here from the viewpoint of Lagrange point 5. So Lagrange point 5 is where stereo A is located. Lagrange point 1 is where the Soho Lasco spacecraft is located, and there is the stereo A coronagraph on the left and the Lasco C2 on the right. So this coronal mass ejection will miss Earth well off to the west. Nowhere near the Earth is this one, although there is one about to strike today. We're expecting it to show up midday or late day today, and another one 2 days after that, as there are two coronal mass ejections about to strike Earth. So L1, that would be the right pane. That's the Lasco C2. And Lagrange point 5, stereo A, would be the left pane. Some great nearly synced images there of a rather significant coronal mass ejection, actually. And let's continue on here. Here's the colorized magnetogram for the past day. Again, this area up here does have umbra, multiple umbra, and this area down here as well. So we're up to 3 sunspot groups at the moment. We'll see if those stick around long enough to get named. Here's 304 angstroms all by itself. And you can see that filament motion there in the western hemisphere, right in this area. So it kind of made a bend and went off to the west, folks. Now the 10.7 centimeter radial flux has dropped all the way down to 81 solar flux units, I believe. A solar flux unit is equivalent to 10,000 joules, by the way. And I think this needs a refresh. Anyway, that's the 1-year chart. The black line is the radial flux. And here's the Space Weather Enthusiast dashboard. And yeah, the radial flux dropped all the way down to 81 despite new sunspot groups forming. I would say it's because there's a rather dense plume of plasma in between the sun and the Earth, essentially blocking the radio signal. In any case, we've got some geomagnetic storms forecasted here by NOAA. So I'm expecting one to show up midday today, basically any moment today, because of the earlier coronal mass ejection that was Earth-directed. This one I agree with. So I'm not agreeing with these calm conditions. I think we actually see some activity kicking up now. So we're expecting a coronal mass ejection to strike today and another one to strike early in the day on the 12th. I don't know about this late in the day 11th stuff, but hey, that's NOAA's forecast. I have no reason to refute it, except that I think there's one CME on the way that wasn't forecasted by NOAA. Let's take a look at global seismicity here. As we've seen some earthquakes, it looks like there's an uptick here in earthquakes over the past 24. And we did report this 6.9 yesterday. So quite a deep quake there. And then some quakes on the other side of the Pacific Ocean as well in western South America. So it looks like the largest of the past 24 was a 6.9 at Vanuatu. And let's just go up the list here, see what else we see. Another very deep quake there, a 4.4 at Fiji. By the way, that 6.9 magnitude quake was at an estimated depth of 520 kilometers. This 4.4 at Fiji, not far away from that 6.9, was at estimated 633.9 kilometers. And that's largely the deep quake capital of the world there, that area in Oceania around Fiji and Tonga, the area north of New Zealand. Papua New Guinea also saw 5.5. If we miss anything on the list, just let us know in the comments. Here's a 4.8 at Chile. That one's at depth as well. Here's a 5.7 at Peru. Another deep quake at Peru there. That's a 4.6 at 138 kilometers. A deep quake at Tonga, 4.3 at nearly 300 kilometers. South Sandwich Islands saw a deep quake at 4.9. So a lot of deep quakes there, including a 4.3 at Fiji. That's at 368 kilometers. That's one of the most recent ones there. That one coming in at 747 today on Sunday, 10/10, October 10th. Welcome to smAsho. Are you familiar with the Cumbre Vieja volcano? Well, here's a great GIF image from SciTech Daily about that, giving some great perspective here on where the urban area is located and the lava flow. So the lava flowing there into the Atlantic Ocean, some new real estate created. And a rather in-depth article here on the volcanic eruption at La Palma. So the new volcanic hotspot in the world, massive amounts of sulfur dioxide being vented from this portion of the planet. The Cumbre Vieja eruption, yes. So lots of spectacular imagery there. If you want to check out the article yourself, it's at scitechdaily.com. Here's some more imagery of the La Palma volcano eruption. A lot of ash and gas. Likely a phreatic eruption happening there. You can see that white cloud there. Something besides volcanic ash, certainly. And let's see what else is on the list. Aviation code red over La Palma. So just checking the list here of today's volcanoes at Volcano Discovery. La Palma's been producing a 10,000-foot plume of ash. Subanose Jima, 7,000-foot plume of ash over the Ryukyu Islands. Kadavar, 5,000-foot ash plume there. Popocatépetl, volcanic ash not observed. Don't assume it's not erupting. You could make magma out of yourself with that sort of thinking. Fuego is exploding, 16,000-foot ash plume over Guatemala from Fuego volcano. Revenador exploding, 16,000-foot ash plume over Ecuador. Sabancaya exploding, 24,000-foot ash plume over Peru. Nevados de Chilean, sporadic emissions enough to produce a 12,000-foot plume of volcanic ash, and a reminder to not pole vault the caldera and to visit our links. If you haven't seen our links yet, visit the links below the video. You can find the red bubble shop there. So don't pole vault the caldera, folks. Please don't pole vault the caldera. It could be unhealthful, and we need the views on YouTube. Okay, it's not that funny, I guess. Today's featured product is Mansa. And we're featuring the purple shirt here. Why? Because I'm currently wearing one. Mansa. Make America not suck again. It's up to you, not giant heaving bureaucracies. So pick up some merch if you want to support the channel via that way. And we appreciate everybody who has picked up merch. The print quality is spectacular. Universum liberate. Forgive, remember, and hold accountable. And if you see somebody committing fraud, please call them on it. Look, it's the face of evil. Saint Dr. Anthony Fauci. Let's look at some magnetic data next. Here's the GOES magnetometer over the past 3 days in a fairly healthy range here. There could be a current sheet polarity crossing happening. I would say it's going to be here by tomorrow. I expected it to be here by today, but there's been a delay. It's a magnetic tug-of-war going on in the sun. Here's the heliospheric current sheet. And I would say by tomorrow, Earth should be in a South Pole-oriented current sheet. It looks like we're not there yet. There's the latest image. Keep in mind that was 1 hour and 1 minute old from when we made the video, and the magnetic environment can suddenly change. Here's a line of sight ecliptic plane field plot showing the solar magnetogram as well. And the main feature remains Sunspot 2882. South Pole current sheet coming. Next, the line of sight coronal hole plot. And we can expect a high-speed coronal hole wind stream in about 3 days from that North Pole-oriented coronal hole there rotating out of the Earth-facing zone. Some South Pole-oriented trans-equatorial coronal holes also rotating in here. So, as forecasted about a month ago, some significant coronal hole activity. Here's a view of it, and I just want to go through some older videos here because one of the advantages that we have to the way we currently format the videos is that you can see the older versions. So if we go back a few days here, so this footage here, this is from the 6th and 7th. This is the 7th and 8th. You'll see the development of these coronal holes. And one of the reasons they're tough to see, folks, is because plasma in the corona obscures them. So we need to use the magnetometer to really get the best data on this. Here's the 8th and 9th. And you can see as that rotates more in the Earth-facing zone, it becomes more visible because the corona is extremely bumpy. If you look at it around the edge of the solar disk, you can see how bumpy indeed it is. And that is why these are often obscured. That's why we have to use this imagery from the Gong 2 data to really truly know where the coronal holes are located. That's using light polarization to determine field polarity. So here you can see this significant coronal hole south of sunspot 2882. If you feel like there's a relationship between coronal holes and sunspots, let us know in the comments. I've got a hypothesis about it, and it'll be revealed when I write a paper about the mechanism behind the sunspot cycles. So here is our solar flare probability monitor, and the probability has gone up since yesterday. I'm going to say solar flare warning continues, especially from sunspot 2882, but also this new spot up here and this new spot down here. Those are both beta class sunspots at the moment. Even though this is only calling them alpha, well, it is showing the southern one as beta. All three of those sunspots are beta class sunspots when we did show prep. So we've got a solar flare warning in effect. A brief little bit of information here about how sunspots are counted. So sunspot number is counted. The sunspot number is determined. R equals 10 times G plus S times K. Yeah. R equals the quantity 10 times G plus S times K, where R is the sunspot number, G is the number of groups observed, S is the count of all sunspots in all groups, and K is a scaling number to compensate for variables. Yeah, it's kind of a weird way to count sunspots, and it has to do with consensus and old school counting. So originally this method was written by Rudolf Wolf in 1848. It's called the Zurich sunspot number. If you want to read about this, go ahead to the Astronomical League. The website is astroleague.org. What is the sunspot number? And yeah, so it's the reason why the sunspot number looks weird. If you're like, hey, there are only 6 sunspots, why is the number 67 sunspots? It has to do with this formula here. Sunspot number equals the quantity 10 times G plus S times K. I hope that helps. If not muddy, if it doesn't muddy the water, I hope it helps. Next, let's look at flaring. So we saw this M-class flare. We covered it yesterday. Since then, only a C-class flare has been the largest intensification. That happened at 2300 was around the peak flux. 2300 yesterday on the 9th. We are seeing a small proton event here associated with that M-class flare. Some relativistic particles made it to Earth. It took a couple of hours. Sometimes these things show up in as little as a half hour. And yeah, so a bit of a proton event there. Again, that solar flare sent some high-speed ejecta our way. We can expect some more as well in about 2 days. Next, we'll look at the real-time solar wind. And the most important factor here is this sudden shift in the BT-BZ. You can see the BT went all the way up to 8, and the BZ all the way down to -8. So 8, -8 for the BT-BZ is significant. And I'm expecting some geomagnetic storm unrest conditions just from the coronal hole wind stream. Now, this could mask the arrival of the coronal mass ejection that we've forecasted. However, there is an ongoing coronal hole high-speed stream density wave here. So this has been going on since yesterday's video, and now it's reached just under 30 protons per cubic centimeter for the maximum density there of that incoming wave. Since it's associated with a strong field, I'd say the likelihood of geomagnetic storms and so on are much higher as a result of that BT-BZ shift, as it is a known factor that when we have a strong BZ component, it is much more significantly affecting the geospace than without that strong BZ component. In other words, we're expecting a high-speed wind to arrive any moment and a coronal mass ejection. So this should be interesting. We may have to make another video today about it. Solar wind speed incredibly low here still, only 292 kilometers per second. Solar wind density still elevated at 24 protons per cubic centimeter. So here's the KP index, and we can expect to see this rise quite a bit in the coming couple of days here. Don't be surprised to see it way up here at a KP6 geomagnetic storm condition. Next 4 hours of modeling of the geospace. You're looking at magnetohydrodynamic pressure here in nanopascals. And you may see an uptick in the pressure here right at the end, I think. Maybe not. Anyway, that's 4 hours of data, magnetohydrodynamic pressure. Here's ground magnetic perturbations. This is modeled in nanotesla magnetic flux density as opposed to nanopascals. When you see pascals, that's a reference to pressure. Anyway, like the last frame, this is 4 hours of data. Since there's a polar excursion going on, and the South Pole has entered the South Magnetic Pole has entered the Southern Ocean there, someplace south of Australia, we show the data daily. This does also show you the likelihood of where auroras would be located. And you see a little uptick there in magnetic perturbations, as we expected to see in the pressure as well. Anyway, it did show up as ground magnetic perturbations. So here's where things are located in the solar system. Mercury just swinging through here. Let's advance this a week. There's where things will be in a week, approaching another full moon. And continuing on to look at a star chart. We show a star chart daily on the channel as well. This is in-the-sky.org. If you want to make your own star chart, just click on charts, click all sky charts, put in your location, and you can make a similar star chart yourself. The yellow line is the ecliptic plane, the path the sun will take across the sky. The blue line is the galactic plane. Let's do a cosmology segment, make it brief. Today's quote random and quote number is 684, which coincides with a low mass X-ray binary / neutron star. I'll just call it a massive radio source and X-ray source, known as 4U 1735-44. A catchy name, and you can see the cyclicity here over the last 16 years of this X-ray source. This low-mass X-ray binary / massive radio source. There are the 30-day hard X-rays from 4U 1735 plus 44. Let's take a look at it visually on the CDS portal. So here is this is the Suzaku X-ray survey. So there is that high-mass X-ray binary and X-ray. And we'll just roll down the list here. I'll pick some other wavelengths. Here's ultraviolet on the Galix. There's the ultraviolet signature from that low-mass X-ray binary. How about optical? DSS is usually pretty good. There it is. It's not so bright and optical. By the way, one of the benefits of the CDS portal is it will show you the spectra. So this is the different wavelengths here, longer wavelengths and shorter wavelengths. And you can see this is a pretty full spectrum low-mass X-ray binary. Let's see what else we've got here. Does it show up on Pan-STARRS? I don't think it's there on Pan-STARRS. How about the G-band of SkyMapper? And there is a little signal there. How about on the 2MASS? Here's the colored infrared spectra. And you can see it's quite cool in terms of thermal emissions. Is there synchrotron radiation? Apparently not. Anyway, again, that's our featured object of the day. 4U1735-44. It's also known as V926 SCO. I don't know which constellation that is. That is a southern constellation, I believe. And there it is once again on the DSS-2 colored. That rather dim, but cyclically X-ray producing low-mass X-ray binary. Are you aware that the 16th is International Observe the Moon Night? Check out this non-time-lapse photography. It might look like time-lapse photography, folks, but it's not. It's from like 2 kilometers away. Let me get rid of the sound here. This is non-time-lapse photography. It's just being filmed from a distance, and you'll be able to see people silhouetted here on the moon. So this is located at Mount Victoria Lookout in Wellington, New Zealand. Some full moon silhouettes there. It's the astronomy picture of the day. You can go check it out yourself at apod.nasa.gov. That's today's cosmology segment. Let's move on to look for charging hazards. We don't see any satellite charging hazards at the moment. Let's take a look at the electron flux. There's a 1-year chart to put it in context. Here's a 3-day chart. And we're seeing fairly low levels here, as we typically do with coronal hole wind streams. So I was a little off with my forecast. I was expecting the electron flux to be up here. The coronal hole wind stream hasn't even showed up as far as the high-speed portion yet. So we'll be keeping an eye on the solar wind data. And when I say eye on, well, the pun is intentional. Here's another diagram of the atmosphere. This is the Earth's Van Allen belts. Distances are shown in miles. Here's the total electron content forecast. The electron density between your GPS handset and your GPS satellite. Most GPS errors occur around the equator around noontime. And this imagery gives us ideas of chaos. Things are looking orderly in the inner Van Allen belt at the moment. Here's another diagram of the atmosphere. This is showing you where the F ionosphere layer is, because our next images are of the F ionosphere and its vibrational frequency. So we are seeing some anomalies here. We're going to show you the anomaly map after this. This is the ionogram in vibrational frequency. Megahertz, millions of vibrations per second. So we are seeing some low and some high frequency anomalies around the Americas. The 2 weakest spots in Earth's magnetosphere are around here, the South Atlantic anomaly, and a smaller one down here, the South African anomaly. And you'll see massive gradations in the ionosphere at those points. So here's the latest image. That's 10:30 Universal Time. Here's the anomalygram showing you departure in megahertz from the 30-day median. High-frequency anomalies shown in blue, low-frequency anomalies shown in red. And you can see some low-frequency anomalies north of the equator there around the Americas, although primarily high-frequency anomalies overall. Also some low-frequency anomalies around the Central Pacific, Hawaii. Anyway, there's the latest image. That's also 10:30 Universal Time. There's the ionogram, and there's the anomalygram. Check out our meteorology segments. Hey, space weather peeps, there's a sneak peek of the meteorology segment. They usually premiere before the daily space weather video. Let's do our bonus features in the form of the El Teide ground-based solar observatory. Hydrogen alpha imagery here. Some of the latest data, only 2 minutes and 39 seconds old. And you can see some brightening here coming out of Sunspot 2882. Again, we've got 2 other sunspot groups have formed since yesterday's video. Here's the latest intensity gram. And we'll check and see if indeed those are sunspots. So up here, that is certainly a sunspot. That's significant. It's a beta class. It's got multiple umbrae. This one down here, same, multiple umbrae. Sunspot 2882 still. Let's just say this. There is a solar flare and coronal mass ejection warning in effect. And I'm talking about additional ones. 3 beta-class sunspot groups currently on the Earth-facing portion of the solar disk. Let's do some close-ups. Some close-ups of Sunspot 2882. So this is 131 angstroms. Shout out to Kimberly. We've placed the Earth scale right below the sunspot here to show you the size of that active region. 131 angstroms and 94 angstroms take 10 images per minute instead of only 2 from the SDO. So if you're making custom movies, you may get additional detail out of those wavelengths. Again, 131 and 94 angstroms, specifically taking more images to study things like solar flares. Here's 1700 angstroms. And you can see that umbra almost the exact same size as the Earth, a little bit larger, actually, than the Earth. And counting the penumbral spot, you've got about twice the area of the two-dimensional space of the Earth covered there. It's quite a significant sunspot. And here's 94 angstroms. We'll close out the video on this wavelength. There is a C-class flare in there somewhere also, folks. Anyway, congratulations on realizing our channel exists. Don't forget to press subscribe if you're new. Don't forget to tell your friends and foes about the world's leading solar forecaster. And may that solar wind be at your back.